Hello students, welcome to the math class. Students, today we are going to start a new chapter, that is Introduction to Three-Dimensional Geometry. In short, it is written as 3D geometry. Let's discuss its objectives first. The very first objective is Cartesian coordinate system in 3D geometry. Second, distance formula. Third, section and midpoint formula. Fourth, to find centroid. These are the four objectives of this chapter. Let's start with the very first objective, that is Cartesian coordinate system. First is the coordinate axis. As in two-dimensional geometry, we are having only two axes, that is x and y axis. Here in 3D geometry, we are having three axes, that is x axis, y axis and z axis. Like this. This is the x axis, the y axis and it is the z axis. Now, the axis opposite to x is called the x dash, opposite to y is called the y dash and opposite to z is called the z dash. Here x, y and z are mutually perpendicular to each other and that's why they are called the rectangular axis. Now, these axes divide the space into different planes. So, next topic is coordinate planes. The plane containing x and y axis, that is, this is the x axis, this is the y axis. So, the plane containing these axes is called xy plane and the plane containing y and z axis is called yz plane. Similarly, the plane containing z and x axis is called zx plane. Now, we will consider the coordinates of point in different conditions. Now, first of all, origin is there, where three axes meet is called the origin and the coordinates of origin are 0, 0, 0. Next is point on x-axis. It is denoted as p x, 0, 0. Next is point on y-axis. It is p0, y, 0. Only y-axis coordinate will be there, others are 0. Point on z-axis, it is p 0, 0, z. Now, we will consider how we will take the point in the planes. First is point in xy plane. Now, as there is a x and y plane, so x and y coordinate will be there and z will be 0. So, p x, y, 0. Next is point in yz plane. It is p 0, y, z. X will be 0. Next is point in zx plane. It is p x, 0, z. In this way, we can consider a point on axis and in plane. Now, as we have already done in two-dimensional geometry, the axes divide the plane in four parts. Those are called quadrant. Here, three axes are there, so they divide the space into 8 parts. So that's why they are called octants. Octant means 8 parts. Now we will check the sign of a point in different octants. So, first is we have to recall the signs of the quadrants. In the first 4 quadrants, write down the signs. It is plus, plus, minus, plus, minus, minus and plus, minus. For the next 4, again repeat this sign in this way. Plus, plus, that minus, plus, minus, minus, and plus minus. Now for the third coordinate, write down the signs. First write down the plus sign 4 times. 1, 2, 3 and 4. And for the next 4, write down the minus sign. In this way, you can remember the sign of the coordinates in the different octants. In this way. So, these are all the basics related to the three-dimensional geometry. Now, we are going to start with the next objective, that is a distance formula. Let P x1, y1, z1 is the one point and second point is Q x2, y2 and z2. We have to find the distance between these 2 points. We are having a formula, that is PQ is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Here one extra point is added as we have done in the distance formula in two-dimensional geometry. Let's discuss its one example. So find distance between the points P minus 3, 7, 2 and the Q point is 2, 4, minus 1. Now again this is a x1, y1, z1 and second point x2, y2 and z2. Now write down the formula as we have already discussed above. It is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square and whole square root. So put the value. The x2 is 2. So 2 minus of minus 3 whole square plus 4 minus 7 whole square plus minus 1 minus 2 whole square. So here it will become 2 minus minus plus sign. So 2 plus 3 is 5 square. Here 4 minus 7 is minus 3 square and minus 1 and minus 2 is minus 3 whole square. So when you simplify it, it will become 25 plus 9 and plus 9. So on solving we will get under root 43 units. Here we have to write down units because distance is always measured in meter or centimeter. But here meter and centimeter is not given. So we will write down the units. Now next formula is there, section formula. We have already done this formula in two-dimensional geometry. So here we will extend this formula for 3 dimension. Now section formula is explained for two type of division, that is internally and externally. Firstly, when the point of division lies between the two given points. Now firstly, say P is given x1, y1, z1 and Q is x2, y2, z2. Here R divides PQ in M1 ratio M2. Now we have done the formula for two-dimensional geometry. Same here. It is M1 x2. We have to multiply M1 on this side and M2 on this side. So plus M2 x1 upon M1 plus M2. Similarly for the y coordinate, it is M1 y2 plus M2 y1 upon M1 plus M2. Third, we will same write in for the z. It is M1 z2 plus M2 z1 upon M1 plus M2. Now second type of division is there when the point of division lies outside the given points. Like this, it is called external division. Now here P and Q are the given points and R lies outside these 2 points. So here formula will be little changed, same as the internally, but we have to put the minus sign here. So coordinates can be written as same here, that is M1 x2 minus M2 x1 upon M1 minus M2. Second, M1 into y2 minus M2 y1 upon M1 minus M2. And third coordinate as M1 z2 minus m2 z1 upon m1 minus m2. Now let's do one question based on these two types of division. Find the coordinates of point which divides the line segment formed by joining the points -2, 3, 5 and 1, -4, 6 in the ratio 2:3 internally. Now word is there internally and externally. So be careful regarding this. So first is given x1, y1, z1 and second is x2, y2, z2. Ratio can be denoted with m1 ratio m2. So it is 2:3. Now firstly write down the formula for internally, that is m1 x2 plus m2 x1 upon m1 plus m2. Similarly for the y, m1 y2 plus m2 y1 upon m1 plus m2, and for the z, m1 z2 plus m2 z1 upon m1 plus m2. Now put the value of x1 y1 z1 and x2 y2 z2. We get 2 into 1 plus 3 into minus 2 upon 2 plus 3, then 2 into minus 4 plus 3 into 3 upon 2 plus 3, then 2 into 6 plus 3 into 5 upon 2 plus 3. Here on simplifying we get 2 minus 6 upon 5, that is minus 4 upon 5. Second, it will become minus 8 plus 9 upon 5. So on solving 1 upon 5. Third, it is 2 6 are 12 plus 15 upon 5. So answer is 27 upon 5. In this way we can find the coordinates of R. Now next kind is there when the division is externally. Now same formula with the minus sign. Now you can check the calculation. It is like this. Again same formula with the minus sign. Now when you put the values you will get here 2 minus plus 6 upon minus 1. Here 2 4s are minus 8 minus 9 upon minus 1. Here 2 6 are 12 minus 15 upon minus 1. So on simplifying we get minus 8, here 17 and it is 3. In this way we can find the coordinates when it divides internally and externally. Now next is condition of collinearity in the three-dimensional geometry. When 3 points are given, we can prove that points are collinear or not by using first is a distance formula, that is sum of any two distances must be equal to the third. We have done the same concept in the 10th standard also. Next we can prove by using the section formula also. Let's take one example based on it. Using section formula, show that A point is 4, 8, 12, B 1, 2, 3 and C 2, 4, 6 are collinear. Now, if these 3 points are collinear, they must lie on one line. So, we are considering let B divides AC in M1 ratio M2 like this. A is here, C is here and B is dividing in M1 ratio M2. Now we will find the ratio for these two coordinates. So by section formula we will apply the formula x is equal to M1 x2 plus M2 x1 upon M1 plus M2. So when you put the value here, B coordinate having 1 as x coordinate. So in place of x put 1 plus here it will become 2m2 plus 2m1 plus 4m2 upon m1 plus m2. So here when you cross multiply like this you will get m1 plus m2 is equal to 2m1 plus 2m2. Here when you collect like terms, m1 shifted to this side and m2 shifted to this side, so they will change their sign. So m1 minus 2m1 will become minus m1. Here 4m2 minus m2 will become 3m2. From here find the ratio. We will get m1 upon m2 is equal to minus 3. Similarly, for the y coordinate, it is m1 y2 plus m2 y1 upon m1 plus m2. So from here, put the value. Again, y coordinate is 2. So in place of y, put 2. Here you will get 4m1 plus 8m2 upon m1 plus m2. Again on cross multiplying, we get 2m1 plus 2m2 is equal to 4m1 plus 8m2. Again, shifting term minus, here it will again become minus. So 2m1 minus 4m1 will become minus 2m1. Here 8 minus 2 is 6m2. So again, when you find the ratio of m1 upon m2, you will get 6 upon minus 2. So after cutting, it is minus 3. Similarly, for the z coordinate, again formula is m1 z2 plus m2 z1 upon m1 plus m2. So here 6m1 plus 12m2 upon m1 plus m2. Here on cross multiplying, we get 3m1 plus 3m2 is equal to 6m1 plus 12m2. Again collect like terms. So it is minus and 3m2 will become minus. So 3m1 minus 6m1 is minus 3m1, and here 12m2 minus 3m2 is 9m2. So from here m1 upon m2 is equal to minus 3. In this way we get the same ratio in all the three cases. So from this, by using the section formula, we can say that A, B, C are collinear points. This is the way to show the collinear point using the section formula. Now let's discuss the midpoint formula and the centroid of the triangle. Now let P x1, y1, z1 and Q is x2, y2, z2 be the two given points, and let R be the xyz be the midpoint of P and Q. So R divides in 1:1. Again we will apply the section formula, and midpoint is called the special case of this formula, because here ratio becomes 1:1. So in place of writing formula, we will directly write down the midpoint as x1 plus x2 divided by 2, second coordinate y1 plus y2 divided by 2, and third is z1 plus z2 divided by 2. By using this formula, we can find the midpoint. Now next is the centroid of a triangle. If 3 points are given, that is the vertices of a triangle, that is A x1, y1, z1, and B is x2, y2, z2, and C is x3, y3, z3 are the vertices of a triangle, then the centroid is the point of intersection of the medians of the triangle. It always divide in the ratio 2:1. So we will remember the direct formula. So it is x1 plus x2 plus x3 divided by 3. This is the x coordinate, and y coordinate is y1 plus y2 plus y3 upon 3, and third is z1 plus z2 plus z3 upon 3 is a z coordinate. In this way, we can apply the formulas directly to find the centroid of a triangle. Students, I hope you got the formulas now and you are able to solve sums given in your SNAP homework and the related sums given in your book with the help of these formulas. Next, we will continue in our next class. Thank you.